Hi everyone. This week we're going to move into a brand new concept. We've spent a lot of weeks learning about quadratic equations, looking at how you can write quadratic equations, analyzing their graphs. We talked about how you can convert between the types of quadratic equations, and we ended the last few weeks on solving quadratic equations. So you guys are pros at quadratic equations. We are going to move into a new concept that still deals with terms that have a square exponent, but we're going to look at a new concept that will specifically help you for geometry next year. This is an algebraic concept that actually works with geometry concepts that have triangles in them. So just like normal, we're going to go through some notes and some examples together. We highly recommend that you watch as much of the video as you feel is helpful. I will let you know in advance, there are 4 examples we're going to go over together. Each example is a little bit different than what the previous example was, so they will be helpful. And the very end of the video has one final concept that will help you with your graded quiz. So we do recommend that you watch the entire video if possible, but if you want to skip some of the middle examples because you feel like you have a good understanding, that's okay. Just make sure you watch the very end of the video. Okay, if you don't have something to write with and paper to write on, if you could pause the video, go grab that, and we will get started on this week's new concept. This week, we're going to be talking about something we call the Pythagorean Theorem. The Pythagorean Theorem is actually, it's a theorem, it's a mathematical understanding that a man actually named Pythagoras developed hundreds of years ago, and we use it still to this day. The Pythagorean Theorem says, for a right triangle with legs A and B and hypotenuse C, A squared plus B squared will equal C squared. So this is the exact definition, but let's break it down a little bit to think about what is this definition telling us? What is this theorem saying? Well, one of the things that we're looking at is we're only going to be focusing on specifically right triangles. Right triangles have 3 sides, A, B, and C, but they're different than other triangles for one particular reason. Right triangles specifically have a right angle. So this theorem only works for triangles that have a right angle. If you're looking at a triangle that does not have a right angle, this Pythagorean theorem, this equation will not work. And we're going to look at some examples of when it works and when it doesn't work. So we know we're focusing on right triangles that have 3 sides, side A, side B, and side C. But one of the things you'll notice is we identify 2 of those sides as legs and 1 side as the hypotenuse. So let's look at a right triangle and make sure we know what is a leg versus what is a hypotenuse. Here I have a right triangle with my right angle, so I know it's a right triangle, and I'm going to identify what's a leg and what's a hypotenuse. Well, the legs are the 2 sides that are directly connected to the right angle. So here's my right angle. The sides connected to that right angle that make that right angle are considered our legs. So we have 2 legs, just like you have 2 legs that you stand on, the right angle also has 2 legs. One of those legs we call leg A, the other one we call leg B. Now it doesn't matter which one you call A or which one you call B, as long as one is A and the other is B. So we have our 2 legs. The third part of the Pythagorean theorem looks at something we call the hypotenuse, which we'll call side C. Now the hypotenuse obviously is the side that's remaining, but you can find it because it's always directly across from the right angle. So I find my right angle, I'm going to go directly across from that, and that long, usually diagonal looking side becomes our hypotenuse, and we call that C. So the hypotenuse is always considered C. What you'll notice from the equation is the hypotenuse is always the longest side. So that's important to remember too. The hypotenuse will always be longer than the other 2 legs. So now that we know how to identify A, B, and C, let's do a little practice on that. we're going to look at 3 different triangles, and we're going to try and label them as with their sides of A, B, and C. So I always look for the right angle first. Here's my right angle. Remember, the 2 sides connected to that make our legs. So we have leg A and leg B. And again, if you switch those, it doesn't matter as long as one is A and the other is B. To find my hypotenuse, I'm going to go back to my right angle, go directly across from it, and that becomes our hypotenuse, also known as side C. All right, let's do the next one. Find my right angle. The 2 sides coming off of the right angle that make the right angle become our legs. So we have leg A and leg B. If you switch them again, that's okay. Go back to your right angle. Go to the side directly across from the right angle. That represents our hypotenuse, also known as side C. Take a second, see if you can do this last one on your own. You might have to draw a little version of it yourself to label. Pause the video, see if you can find A, B, and C, and then turn it back on again to check your work. All right, let's look at this last triangle here. I always start in my right angle. I'm going to look at the 2 sides that are connected to the right angle that make that right angle. One is going to be A, the other is going to be B. Again, it doesn't matter which is which. Go back to my right angle, go directly across from it, and now I found my hypotenuse, or side C. So now we know how to identify side A, B, or C. Let's move on to really thinking about the Pythagorean theorem and how we can use it. We know that the Pythagorean theorem says A squared plus B squared equals C squared. We're going to come back to this a lot as we go forward, because the Pythagorean theorem allows us to find lengths of missing sides. Maybe I only give you 2 lengths, so you can use the Pythagorean theorem to find the 3rd length. Just like normal, there are some steps that you can use to help you solve this. I would take a moment, write the steps down if you can, and then we'll go over them. The first step in using the Pythagorean theorem to identify a missing side is to make sure you correctly identify A, B, and C on the triangle, the skill we just practiced. Once you've identified A, B, and C, think about which side is missing. Are you missing the length of A? Are you missing the length of B? Or are you missing the length of C? Once you know, what sides you do know and what side you don't know, you then can plug in your measurements to our formula of A squared plus B squared equals C squared. Now you have an equation with one unknown, so your final step is to solve for that unknown. So let's use these 4 steps to solve for our first missing side. Here's our first example. So my first step, I'm going to zoom out a little bit so we have our steps identified there for us. Okay, step 1 says to identify A, B, and C on the triangle. Okay, we know how to do that. Start at your right angle. The 2 sides represent our legs. So I'm going to call this leg A and this leg B. Go back to my right angle, go to the side directly across. That's going to be leg C. And what I notice here is there's no measurement. So step 2 says identify which side is missing. Well, I'm missing side C. I know the measurement of side leg A and I know the measurement of leg B, but I don't have a number or a measurement connected to the hypotenuse of C. So because I now have identified what side is missing, I can plug in my measurements to our Pythagorean theorem. So let's do that. The Pythagorean theorem says A squared plus B squared equals C squared. So I'm gonna now use this to help me. I'm gonna plug in my A value if I know it, my B value if I know it, and my C value if I know it. But one of those, remember, we don't know. Do I know A? Yes, A is 3. So this equation becomes 3 squared. Plus, what about B? Do I know B? Yes, B is 4. So that becomes 4 squared. Bring down the equal sign. Do I know C? I don't know C, so I'm going to leave C as a variable of C squared. Now I have an equation with one unknown that I can solve for. So we're going to do a little simplifying. I see here 3 squared. What is 3 squared? 3 times 3 is 9 plus 4 squared. What's 4 squared? 4 times 4 is 16 equals, I don't know this yet, so I'm going to leave it as C squared. Okay, I see a little math I can do. I see 9 plus 16. What is 9 plus 16? I'm going to combine those like terms. That becomes 25 equals, and I still have C squared. So I'm really close to solving for my unknown, but I need to get c by itself. C by itself, how do I get rid of that exponent 2? Well, this is something we learned a couple weeks ago. The inverse of a squared exponent is to square root that, because that will cancel out my exponent of 2. Whatever you do to one side, you have to do to the other. And now I can solve. What is the square root of 25? Well, remember, there's always two answers. It could be -5 or +5 equals c. But only one of these square roots is reasonable. Does it make sense to have a -5 measurement of a triangle? No. So we know that our correct answer is the positive square root, which is 5. So I can say that the length of the missing side is c. Sorry, the length of the missing side is 5. So now I know all of the lengths of my triangle. If I wanted to write the full Pythagorean theorem, I would say 3 squared plus 4 squared equals, and I just solved that c is 5 squared. And now I have the Pythagorean theorem that represents this right triangle. Let's try another one. If you want to pause the video and try this one on your own to then check your answers, you can always do that too. All right, let's take a look and see what we have for a triangle. I notice that I have my first step. I'm going to identify A, B, and C. I see my right angle here, which means my two legs are A and B. I'm going to call this one A and this one B. Across from the right angle is side C, which has no measurement, so that means I need to find hypotenuse C. I need to look for C. So let's plug it into our equation. A squared plus B squared equals C squared. Do I know A? Yes. That becomes 2 squared plus B squared. Do I know B? Yes. This is 3 squared equals, do I know C? No. So that stays C squared. Now I have my formula and I'm ready to simplify and solve for my unknown. 2 squared is 4 plus 3 squared is 9 equals C squared. Okay, 4 plus 9 is 13 equals C squared. All right, I'm almost getting C by itself, but remember, I have to get rid of that exponent, so I'm going to square root both sides to cancel that exponent. Now, this is an interesting one. This is why this one's a little different than the one before. Is there a square root of 13? No. So we're just going to say that the square root of 13, we're not actually even going to solve it. It's a really long decimal. We don't need to do that. We can keep it most accurate by just leaving it the square root of 13 equals C. And we're done. That tells us that the length of the hypotenuse is just the square root of 13. That can be your answer. It feels super strange, but it is accurate. So again, if I want to plug this in, I now know that my C value is the square root of 13. Okay, let's move on to another example. This one's even different than our first two examples. First step, identify A, B, and C. I see my right angle here, so I'm going to look at the two legs. I notice I have a leg of A and a leg of B. This one's interesting. I don't have a measurement connected to my B right here. But let's look at our last side and go across from my right angle. I have a 6 that represents C. So in this example, I'm missing B. I have to find B. So let's figure what B is. We're going to go back to our Pythagorean theorem. A squared plus B squared equals C squared. Let's plug in what we know. Do we know A? Yes, A is 4. So that becomes 4 squared. Plus B. Do we know what B is? We don't know what B is, so we leave B just the same. That's our unknown. Equals C squared. C squared is 6. 6 squared. All right, now we're ready to do our last step, which is solve for our unknown. This time we're looking for a leg, but we're still going to simplify and solve. 4 squared is 16 plus B squared, we don't know, equals 6 squared, which is 36. Great. Now this one's a little different because I'm trying to get B by itself. So what I notice here is I have to get rid of this 16. How do we do that? we do minus 16 from this side and minus 16 from this side. So what are we left with? B squared equals 36 minus 16 is 20. Perfect. Now I'm trying to solve for B, so I'm going to square root to get rid of that exponent. Whatever I do on one side, I have to do on the other. I'm left with just B on this side, square root of 20. Can you do the square root of 20? You can't do the square root of 20. So we just leave our answer as the square root of 20. And we just found our missing side. The length of side B is the square root of 20. Sound good? Let's move on to one final example. All right, here we go. Again, if you want to pause the video, try this on your own and then check your answer. That's a really good way to practice. All right, first step, identify A, B, and C. So I start at my right angle. I go to the two sides connected to it. One of them is A. Uh-oh, I notice here I have no measurement for side A, and the other one is B. I do have a measurement for B. We're gonna go across from the right angle, and we're gonna get a C. All right. In this one, I can identify that my missing side is side A. So our goal is to find A. What is the A value for this side? Okay, here we go. Start with our Pythagorean theorem. A squared plus B squared equals C squared. Plug in the values that we know. Do we know A? No, we don't know A, so we're gonna leave that as A squared. Plus B, do we know B? Yes, B is 12 squared equals C. Do we know C? Yes, C is 15 squared. Perfect. Now we're ready to solve for our unknown of A. A squared is gonna stay the same because I don't know that, plus 12 squared. What's 12 times 12? 144 equals 15 squared. I actually don't know off the top of my head what 15 squared is, so I'm gonna do it on my calculator. 15 times 15, or 15 squared, is 225. Great. I'm trying to solve for A, which means I have to get rid of everything except for A, so I notice I have to get rid of this constant right here. Using inverse, I'm going to minus 144. Whatever I do on one side, I have to do on the other. That cancels, and I'm left with just A squared equals, let's do that math. 225 minus 144 is 81. All right, I'm getting really close, but I need to get that A by itself. How do we get rid of that square? We square root it. That cancels our square. Whatever you do to one side, you have to do to the other. So I'm left with just A equals, and remember for triangles, we only take the positive square root. What's the square root of 81? 9. So what's the length of our missing side A? 9. So I could plug this back into my Pythagorean theorem by saying A squared, which we now know is 9 squared, plus B, which was 12 squared, equals C, which is 15 squared. And we know that this equation represents that right triangle. Hopefully you're feeling pretty good about the Pythagorean theorem examples. We're going to do one final concept using the Pythagorean theorem to decide whether a triangle is a right triangle or not. So you'll notice on these triangles, I don't have the right angle in there because we don't know if it's a right triangle or not. So we can assume, we can make a really educated mathematical guess as to where the right angle would be. Now remember, the hypotenuse is always the long side anyway, so that's gonna help us. We're gonna use our Pythagorean theorem, A squared plus B squared equals C squared, and all three measurements to decide, is this a true equation or not? So we know that the C side, our hypotenuse, is always the longest. So we know that this is going to be our C value. That means the right angle may be there. That means that one of these other legs is A and the other one is B. So I labeled, and now I'm just going to plug in and see if it's a true equation or not. A we said is 4, so I have 4 squared plus B squared, or 3 squared, equals C is 5, 5 squared. And now I just get to simplify and solve. Let's see, 4 squared is 16 plus 3 squared is 9 equals 5 squared is 25. Is this true? Does 16 plus 9 equal 25? Well, what's 16 plus 9? 16 plus 9 is 25. 25 equals 25. Yes, this is a right triangle. So I was able to take the three sides, plug them into my equation, and see, does this make a true equation? If it does, then yes, this is a right triangle. Let's try this one. Again, we're going to use our Pythagorean theorem. A squared plus B squared equals C squared. All right, let's identify A, B, and C. Remember, our longest measurement represents C, our hypotenuse. So here's my long measurement, my 8. So that's going to be my C side. That means that the right angle is across from it. It's probably here if it's a right angle. So that would make one of these sides A and the other side B. All right, let's go plug in and see. A we said is 6. 6 squared plus B we said was 5. 5 squared equals C we said was 8. 8 squared. All right, let's simplify and see if it's true. 6 squared is 36 plus 5 squared is 25 equals 8 squared is 64. All right, let's add 36 plus 25. 36 plus 25 is 61. I think I'm going to double check on my calculator just to make sure. Yes, 36 plus 25 is 61. Does 61 equal 64? No, it does not. This does not equal. It's not true. So this is not a right triangle. See how I plugged my numbers in and I simplified and solved all the way down to get a not true equation. That makes this not a right triangle. Let's do two more examples over here. This time I'm just given side measurements. I'm not actually even given the triangle, but I can use this to still identify A, B, and C and plug it into my equation to see. We're going to do a little work over here. All right, I have a 9, an 11, and a 7. So from here, what is A, B, and C? The longest side represents C, so that means 11 is going to be our C value. So the other two then are A and B. Doesn't matter which one is which. Now we're going to plug it in. I'm going to start up here. A squared plus B squared equals C squared. Okay, what did we say? A was 9. 9 squared plus B is 7. 7 squared equals C is 11. 11 squared. Let's see if this is true or not. 9 squared is 81 plus 7 squared is 49 equals 11 squared, 121. Let's check and see. I'm going to get my calculator out so I'm not guessing. Let's do this math here. 81 plus 49 equals 130 equals 121. Is that true? That is not true. This is not a right triangle. It does not work with the Pythagorean theorem, which means there is no right angle there. Let's do one more. We changed some of the numbers. We have a 9, a 12, and a 15. All right, the longest side is our C. So I see a 15, that's going to be our C. That means the other two are A and B. All right, here we go. Let's see if I can fit all my math work on here. We're going to do A squared plus B squared equals C squared. What's our A value? 9. So we're going to say 9 squared plus, what's our B value? 12. 12 squared equals, what's our C value? 15. 15 squared. All right, let's use that and do some math. 9 squared is 81 plus 12 squared is 144 equals 15 squared. Oop, I don't remember what that is. So let's do a little math. 15 times 15 is 225. All right, let's do a little adding. Is 81 plus 144? 225. So does 225 equal 225? Yes, it does. So this, yes, is a right triangle. 9, 12, and 15 do make a perfect right triangle. Wow, we just did a lot of work with the Pythagorean theorem. We were able to identify missing sides. Sometimes we identified when the side missing was the hypotenuse, the long side. We solved for that. Other times, we were able to identify a missing leg, either A or B, using the Pythagorean theorem and square roots. And then finally, we identified whether a triangle is a right triangle or not, again using the Pythagorean theorem. There are some really good practice opportunities this week. We highly recommend that you practice them before you take the graded quiz. As a reminder, you can take the graded quiz 3 times to get the highest score possible. So we recommend taking it once. If you're not happy with your score, take it, go do some practice and then go take it again to improve your score. But if you don't do practice in between, it makes it really difficult to improve your score because you might not be able to learn from the errors you made the first time. The other thing we want to remind you is one of the things that teachers are looking at is that you're actually completing the graded assignment and that you're scoring above a 50%. So we highly recommend taking that assessment as many times as you can to get a score that's as high as possible and above a 50%. You guys are doing a really good job. I know this was a long video, so if you hung in there, nice work. And let us know, send us an email, come to our office hours on Tuesdays and Thursdays at 12:45 to 1:30 if you have any questions. Miss you guys and good luck and have fun with the Pythagorean theorem this week.